Hello and welcome to Algebra 1, Lesson 33. In this video, we're going to learn about dividing polynomials by monomials. So far, we've learned how to add and subtract with polynomials, and we've learned how to multiply polynomials. Now, the next logical step is for us to learn how to divide polynomials. But before we get into the more serious division, we want to start out with something that's very basic, very simple, and that's dividing a polynomial by a monomial. And before we kind of jump into that, we need to go over a few things from pre-algebra first. So I want you to recall, if I have something like a plus b over c, legally I can write this as a over c plus b over c. These two are the same. Now I know in this kind of general form it might not look familiar to you, but all we're saying is that if we have a common denominator, in this case we have a common denominator of c, I can write the sum of the numerators, which is a plus b, right? This numerator is a, this numerator is b, so the sum of the numerators over that common denominator of c. As an example with whole numbers, so let's say you saw something like 20 plus 4, and this is over 2. Well, I can legally split this up into 20 over 2 plus 4 over 2. And we can see that we get the same answer either way. If I just evaluated this, 20 plus 4 is 24. If I divide it by 2, I get 12. If I do it this way, 20 over 2 is 10. 4 over 2 is 2. So 10 plus 2 is 12 also. And what you're used to seeing is you're used to seeing this and going to this. And all I'm saying is that it's the same either way. I can start out kind of in this format and go to this format. And that's what we're going to need to do in this lesson. So as another example, let's say you saw something like negative 9 minus 6 over 3. Again, I can split this up and say I have negative 9 over 3 plus negative 6 over 3. This is just a common denominator here of 3. And I could just go back and forth between these two, right? These are the same. And again, to kind of prove that, if I take negative 9 and I subtract away 6, I get negative 15. Then negative 15 divided by 3 would be negative 5. If I kind of do it this way, negative 9 over 3 is negative 3. And then negative 6 over 3 is negative 2. So you would have negative 3 minus 2, which again is negative 5, right? So either way, it's the same result. All right, so now that we have that little fun fact under our belt, we're going to cover how to divide a polynomial by a monomial. So remember, a monomial is a polynomial that is one single term. So we're dividing by one single term. So in other words, the divisor in each case will be a monomial. So to divide a polynomial by a monomial, we want to divide each term of the polynomial by the monomial. And we're going to use the technique we just saw when we looked at those examples with whole numbers. So starting out with this first one, we have 2k cubed plus 18k squared plus 18k divided by 6k squared. So the first thing I want you to do when you get this problem is set it up as a fraction. So what I'm going to do is I'm going to write this as 2k cubed plus 18k squared plus 18k, and then I'm going to put a fraction bar, and then my divisor is going to go as the denominator. So I have my numerator, or my dividend, which is 2k cubed plus 18k squared plus 18k. And then it's divided by, we have our divisor, or the denominator, 6k squared. So in order to set this problem up, it's very, very simple. Again, I'm just going to split it up into each term of this polynomial up here in the numerator, divided by this monomial down here in the denominator. It's just that simple. So I would say I have 2k cubed over 6k squared, plus, next I have 18k squared over 6k squared. Then next I have plus 18k over 6k squared. And again, this is perfectly mathematically legal. I have a common denominator here of 6k squared. So I could go right back and write it this with the sum of the numerators, 2k cubed plus 18k squared plus 18k over that single common denominator, right? So it's perfectly legal to go back and forth. So once we have set it up in this format, all we want to do is simplify each part separately. So in other words, I'm going to go through, starting here, and say, okay, if I have 2 over 6, I know I can cancel a common factor of 2. So this is going to cancel and be 1. This is going to cancel and be 3, right? 6 divided by 2 is 3. And then k cubed over k squared, we know that that would be k raised to the power of 3 minus 2. So this is going to cancel, and this is going to be a 1, right? So that's k to the first power. So let's go ahead and put equals, and then we'll write the results as we go. So this is k to the first power, or just k, over just a 3 in the denominator. And then plus, if I look at this right here, I have 18k squared over 6k squared. Well, 18 divided by 6 is 3. K squared over k squared is 1. So this is going to cancel completely. That's going to be 1. So then plus, I'm going to put a 3 here. And then lastly, I have plus 18k over 6k squared. So 18 divided by 6 again is 3. K over k squared. So this is k to the first power. So remember, if you use your quotient rule for exponents, this is going to be k to the power of 1 minus 2, or k to the power of negative 1. K to the power of negative 1 is what? It's 1 over k. So essentially just eyeballing that, you can see that this cancels out with one of the factors of k here. You just have a k to the first power in the denominator. So this would be plus 3 over k to the first power, or just 3 over k. So this is your answer. You get k over 3 plus 3 over k. Now, I want you to remember something else from pre-algebra. Let me scroll down and get a little room going for this. Let's say that I had something like 20 divided by 4, and we all know this is 5. So I have my dividend. This is my dividend. This is my divisor. And then this is my quotient. So how can I check the result? Remember, I can go backwards. I can take the quotient and multiply it by the divisor, and I should get my dividend back. So in this particular case, this is our quotient. So I should be able to multiply this quotient by our divisor. Remember, the divisor is 6k squared, and then I should get the dividend back, the 2k cubed plus 18k squared plus 18k. So let's check that out. Okay, so I'm going to multiply this guy by 6k squared. And again, all I'm going to use is the distributive property. So 6k squared times k over 3. Let's just write that out like this. So 6k squared times k over 3. Well, we know that the 6 would cancel with the 3 and give me a 2. And then k squared times k is k cubed. So for the first part, I'm going to put 2k cubed. Let me erase this. Then we have 6k squared times 3. Well, that's easy. It's just 3 times 6, which is 18. And then k squared comes along for the ride. And then lastly, I have 6k squared times 3 over k. So 6k squared times 3 over k. Well, we can see that one of the factors of k here would cancel with this k. And I'd have 6 times 3, that's 18, so 18k. So plus 18k. So let's see if this was our original dividend. So we scroll back up here and we see that it was 2k cubed plus 18k squared plus 18k. 2k cubed plus 18k squared plus 18k. So because we multiplied our divisor by the quotient and it gave us the dividend back, we know we have the correct answer. So it's very important, especially when you first start, to go back and check your answer. Make sure that you got the correct one. That way, if you didn't, you can correct the mistake right away. All right, let's take a look at another one. So we have 8r to the 5th power plus 12r to the 4th power plus 8r cubed divided by 4r cubed. So again, I'm going to write this as a fraction. So I'm going to write this as 8r to the 5th power plus 12r to the 4th power plus 8r cubed. That's the numerator, right? That's the dividend. So then this is divided by 4r cubed. And then I'm just going to split this up, right? This is just a common denominator. So I'm going to say this is 8r to the 5th power over 4r cubed plus 12r to the 4th power over 4r cubed plus 8r cubed over 4r cubed. And then once I have it in this format, it's very easy to go through and simplify each part. So let's take a look at that. We know that 8r to the 5th power over 4r cubed, the 8 would cancel with the 4 and give me a 2. R to the 5th power over r cubed is r squared. So then let's go ahead and write these as we get them. So this would be 2r squared. Then over here I have 12r to the 4th power over 4r cubed. 12 would cancel with 4 and give me a 3. R to the 4th power over r cubed. This would cancel and be r to the 1st power. So this is plus 3r. Then lastly, I have 8r cubed over 4r cubed. This is going to cancel with this and give me a 2. R cubed will cancel with r cubed. So this will be plus 2. So I get 2r squared plus 3r plus 2. And again, very, very easy to check. All I'm going to do is take this answer here, 2r squared plus 3r plus 2. This is the quotient, and I'm going to multiply it by the divisor, 4r cubed, and I should get the dividend back. So 4r cubed times 2r squared is 8r to the 5th power. 4r cubed times 3r is plus 12r to the 4th power. And then 4r cubed times 2 is plus 8r cubed. So what I get is exactly the dividend that I started with. 8r to the 5th power plus 12r to the 4th power plus 8r cubed. 8r to the 5th power plus 12r to the 4th power plus 8r cubed. All right, let's take a look at another one. We have negative 3x cubed plus 24x squared minus 4x, and then we're dividing by negative 8x squared. So I'm going to take negative 3x cubed plus 24x squared minus 4x. This is going to be my numerator, right? That's the dividend. And I'm dividing this by the divisor. That's going to be my denominator, negative 8x squared. And so once I have this, I'm just going to split it up into 3 different parts here. So negative 3x cubed over negative 8x squared. And then plus 24x squared over negative 8x squared. And then I have a minus here, but I think it's a little better if we put plus negative 4x over negative 8x squared, just so we don't make a silly sign mistake. All right, so let's take a look at this piece by piece. So the first thing is I have negative 3 over negative 8. Can't really cancel anything other than the negatives, right? Negative over negative is positive. And then I have x cubed over x squared. So this is going to cancel. This will be x to the 1st power. So for the first part, we'll have 3/8 times x, or 3x over 8. You could write it that way too. Doesn't really matter. Then the next part we have a positive over a negative. So I know that's going to be a minus. 24 over 8 is 3. So this will cancel and become a 3. And we know it's negative 3, but I've already accounted for that right there. Then x squared will cancel with x squared. So basically this is just minus 3. Then for the next part here, I have negative 4 over negative 8. Negative over negative is positive. And then 4 over 8, this is going to become a 2 right here, right? Because 8 divided by 4 is 2. Now when I look at x and x squared, this is going to cancel completely. So the numerator is now a 1. And then down here, I'm going to take one of these factors of x away. So this would be x to the 1st power. So essentially what you'd have is plus 1 over 2x. And again, if we want to check this, we'll take this quotient here and multiply it by the divisor, and it should give me this dividend back. So let's try that out real quick. So we'll do 3/8x minus 3 plus 1 over 2x. And we're multiplying this by the divisor, which was negative 8x squared. So let's see what this gives us. So negative 8x squared times 3/8x. So let me write that out so you can see what's going to cancel. So obviously, this 8 will cancel with this 8. I'll basically just have a negative 1 there. Negative 1 times 3 is negative 3. So that's negative 3. And then x squared times x is x cubed. Then next I have negative 3 times negative 8x squared. Negative times negative is positive. 3 times 8 is 24. So plus 24x squared. Then lastly, I have negative 8x squared times 1 over 2x. So negative 8x squared times 1 over 2x. This is going to cancel with this and give me a 4. And x squared over x, this would cancel with one of these. So basically, I'd have negative 4x there. So minus 4x. And we could scroll back up and see that that is our dividend. Negative 3x cubed plus 24x squared minus 4x. All right, let's take a look at another one. We have 24a to the 5th power b plus 2a to the 4th power b squared minus 18a cubed. And then this is divided by negative 6ab squared. So let's kind of shortcut this. And instead of writing this as a fraction and then kind of splitting it up, let's just split it up right away. So I'm going to take this term right here, this 24a to the 5th power b, and write it over the divisor here, negative 6ab squared. Then plus, I'm going to have 2a to the 4th power b squared over that divisor, negative 6ab squared. And then I have that minus, let me put plus negative 18a cubed over, again, negative 6ab squared. Anything I can do to kind of give you a shortcut, because a lot of times you're going to be doing this on a timed exam, and you don't want to take 2 steps when you could do something in 1. So let's simplify each part kind of separately. 24 over negative 6 would be negative 4. So this would cancel with this and be negative 4. Then a to the 5th power over a, this would cancel and this would be a to the 4th power. Then b over b squared, this would cancel and this would be b to the 1st power. So kind of the first part here would be negative 4, a to the 4th power over b. Then if I move on over here, I see that I have 2 over negative 6. I know this is going to be negative, so let me just go ahead and put a negative out in front. That's going to go right there. 2 over 6, this is going to be a 1, and this is going to be a 3. Right? 6 divided by 2 is 3. Then we have a to the 4th power over a. This is going to cancel with one of these, so instead of 4, this will be 3. And then b squared will cancel with b squared. So what I'll have here, I have the minus, and then I'll have a cubed in the numerator over, and the denominator, I'll just have a 3. Right? I've already accounted for that negative. All right, then next, I move on over here. I have a negative over a negative. I know that's going to be positive. And then 18 over 6 is 3. A cubed over a, this is going to be a squared. And then b squared, I don't have anything to kind of match up with that, so that's just going to stay. All right, so then it's going to be plus, we have 3a squared over, in the denominator, b squared. So here's our answer. Negative 4a to the 4th power over b minus a cubed over 3 plus 3a squared over b squared. So I'm not going to check this one just in the interest of time, but go ahead and pause the video if you're interested. Take your quotient here, the negative 4a to the 4th power over b minus a cubed over 3 plus 3a squared over b squared. Multiply it by the divisor. Okay, multiply it by the divisor, which we know is negative 6ab squared. And you will get the dividend back. 24a to the 5th power b plus 2a to the 4th power b squared minus 18a cubed. So go ahead and pause the video if you want. Take a look at that. And then we're going to do one more problem. All right, for the last one, I have 1/8 x to the 4th power y squared plus 4/5 x cubed y minus 1/2 y cubed. And this is divided by 12xy. Now, before we kind of look at this, I want you to recall that if you're dividing a fraction, so something like 3/4 by a number or another fraction, how do we do it? We take the first fraction, we multiply by the reciprocal of the second. So if I had 3/4 divided by, let's say 10, I would say this is 3/4 times the reciprocal of 10, which is 1/10. Right? And you could write this as 10 over 1 if that makes it easier for you. So instead of sitting here and saying, okay, I have 1 x to the 4th power y squared over 8, and this is divided by 12xy. I know in the end, I'm going to write this over 1, and this is going to be equal to, x to the 4th power y squared over 8 times the reciprocal of this guy, which is 1 over 12xy. I can just start out. I can make this much simpler and write this as kind of a multiplication problem. I can see this and say, well, instead of dividing by 12xy, I can kind of say this is times 1 over 12xy. It's the same thing. If I were to multiply 20 by 1/2, it's the same thing as if I divided 20 by 2, right? Same thing. So doing it this way is just going to make it simpler for us. We would have x to the 4th power y squared over 8 times 1 over 12xy. Again, if I did it using division, after I do my multiply the first guy by the reciprocal of the second, I end up with this anyway. So I might as well start out doing that. Again, if you have something that normally takes 2 steps, if you can cut it down to 1, it's just going to put you 1 step ahead. All right, then plus. We have 4x cubed y over 5 times 1 over 12xy. Then we have minus. When I'm going to put plus negative, we have y cubed, or you can put 1y cubed, doesn't matter, over 2, and again, times 1 over 12xy. All right, so let's take a look at this now. So what can we cancel? Well, here I'm cross-canceling. I can cancel one of the factors of x. This will be x cubed with this x here. I can cancel one of the factors of y. This will be y to the 1st power with this y. And then nothing else I can really do. So in the numerator, I'm going to have x cubed y. In my denominator, I'm going to have 8 times 12, which is 96. Then moving on to this part here, I can easily see that 4 would cancel with 12 and leave me a 3 down here. One of the factors from x cubed would cancel with this x here. This would be x squared. Y would cancel with y. So I would have x squared over 5 times 3, or 15. So this is plus x squared over 15. And then for the last part here, I have y cubed over y. So one of the factors of y cubed would cancel with this. So this would be y squared. And then nothing else I can really cancel. So you'd have negative y squared. I could put minus y squared over 2 times 12 is 24, and then times x. So 24x. So this is what we end up with as our answer. X cubed y over 96 plus x squared over 15 minus y squared over 24x. And again, if you want to check this, take your answer here, multiply it by the divisor. Remember, when we started out, this problem was dividing by 12xy. So that's your divisor. And again, I modified it just for the sake that we were working with fractions, and it made it easier. But when you do that, you should get that original dividend back.